Okay, so now let's look at arcs, sectors, and segments. Arcs, sectors, and segments. And we're going to start off with an arc. So what is an arc? An arc is a piece of the circumference of a circle, right? If I had a complete circle like this, right? A piece of that circumference, maybe from there to there, this piece is an arc, right? And an arc can be tracked back to a center by two radii. So there's a radius and a radius. And between the two radii, there's an angle theta. So this arc here, right, is linked to the center by two radii and an angle theta. So we want a formula to find the length of arc, how long the arc is. So the formula for length of arc that we use, length of arc, is theta over 360 times 2 times pi times r. So theta over 360 times 2 pi r. To make it short, I think it will be much simpler just to say theta over 360 times 2 pi r. Okay, that's how you find length of arc. So let's just try a quick example there, right? Let's say, for example, I have a shape like this. Radius is 7 centimeters. The length there is, let's say, 60 degrees. Yeah, that's it. The length of this arc here from there to there, that's the length. L is going to be theta, which is 60 over 360 times 2 times pi, which is 22 over 7, times our radius, which is 7. So if we're to do our calculations, this cancels that. And then 6 into 360, that's 1 over 6. 2 times that, that's 1 over 6 times 44, which gives 44 over 6, which gives 7.3 centimeters. So that's the length of your arc there. Now, let's proceed now to the sectors. So a sector is not to be confused with an arc. Sector is the entire slice of pizza-like shape. So if you think of a slice of pizza shape, that is your sector. So a sector, now we're looking at everything inside. What's inside? We're not looking at the boundaries. We're looking at what's inside. So we have the same things. We have the angle theta. We've got a radius and a radius. So area of a sector now is theta over 360 times pi r squared. So theta over 360 times pi r squared. That's our formula for finding area of a sector. So again, we'll just try a simple example. I have a sector like this with a 90-degree angle, and for simplicity's sake, I have 7 centimeters, and then my area will be theta over 360, 90 over 360, times pi r squared, 22 over 7 times 7 squared, right? Again, this can be done with your calculator. You can use the pi from the calculator, but I'm just simplifying things for sake of example. So that's 1 over 4. If I simplify 90 over that, 7 into that, 7 times that, that's going to give you 7 times that is going to give us 168, right? And then that's going to give us 42 centimeters squared. So that is, I hope this is correct, but that's generally how you go through the working, right? Usually you submit this to your calculator, but for example's sake, I'm just working through it. So that's how you find area of a sector. Now the last part is a segment. The last part is a segment. Now, if I have a sector like this, if I cut the sector, I'll split it into two shapes. On one side, I have this shape. This shape is what we call the segment. And then on the other side, I have this shape. This shape is a triangle. So what we're seeing is that a sector can be split into two pieces, a triangle and a segment. So for me to find area of a segment, I must know the area of the entire sector and then subtract the area of the triangle. So the formula for finding area of a segment is going to be area of sector minus area of triangle, right? Area of a sector, we know it is theta over 360 times pi times radius squared. Our area of a triangle is going to be, in this case, half AB sine theta. But let's look at a sector and make sense of it. If this is R, that's R, and that's theta there. A and B are R and R. So R times R gives you R squared. So instead of half AB sine theta, it's going to be half R squared sine theta, because your A and your B were multiplying, were actually R, and R times R, it gives you your R squared. So area of a segment is equal to area of a sector minus area of a triangle, which is theta over 360 times pi r squared minus r squared sine theta. So that is where we'll stop, and that's the end of plane shapes. You'll need to move on to solid shapes.